of an alpha particle during an alpha decay process. First of all, I would like to show you the outline of my presentation. First, I will be talking about the alpha particle. Next will be about the alpha decay. After that, about Gamows' theory of alpha decay. Next will be the Geiger-Nuttall law. And finally, review. So first, about the alpha particle, we should know what it is first. So what is the alpha particle? Alpha particle is basically just the nucleus of a helium. So we can imagine the helium atom, but without the two electrons. So that means the alpha particle has two protons and two neutrons. Therefore, it has a mass number of 4. Next, we will talk about the alpha decay. What is alpha decay? Alpha decay is when a large size nucleus, usually with a mass number of 210 over 210, transforms into a different nucleus by the emission of an alpha particle. As we can see in the figure here, a larger size parent nucleus turns into a smaller size daughter nucleus by losing some of its nucleons in the shape of a alpha particle. So now there's a question arises. Why does alpha decay only happen for large size nuclei? The answer is none other than the nature of the forces inside the nucleus. So inside the nucleus, there is the nuclear force, which is the attractive force between the protons and neutrons. And then there is the Coulombic force, which is the repulsive force between the protons. The neutrons do not experience the Coulombic force because they are neutral. So now typically inside a nucleus, the nuclear force is larger than the Coulombic force. It dominates over the Coulombic force, keeping the nucleus together. But the larger the size of a nucleus, the larger the distance of the nucleons. Therefore, the larger the Coulombic force as well. This causes the nucleus to become unstable. And the only way for a large nucleus to stabilize itself is by decreasing its size, by losing some of its nucleons. This is basically what happens during an alpha decay process. Now, there is an interesting puzzle regarding the alpha decay. But first of all, we should look at the nuclear potential diagram. So what is this diagram? This diagram is, well, basically inside a nucleus, there are all of the particles experience a nuclear potential due to all of the interactions inside the nucleus. So for example, in our case, the alpha particle inside the nucleus experiences a square potential well. But as it goes outside the nucleus, it experiences a Coulombic potential. Now, if we look at different alpha particles from different alpha decay processes, we see that the maximum kinetic energy of the alpha particle usually ranges around 4 to 10 mega electron volts. Meanwhile, if we look at different large size nucleus configurations, we see that the nuclear potential height is usually around 25 mega electron volts. So the question is, how is it possible that a particle with much less energy than the potential barrier managed to escape from it anyway, as we know that the alpha particle only has an energy of 4 to 10 mega electron volts. Meanwhile, the potential barrier has 25 mega electron volts. we can visualize this by imagining imagine if we throw a ball upwards. Um, if we throw a ball upwards, the ball would come back down, right? Unless if we throw the ball with a velocity of over the velocity of Earth's Earth's escape velocity. Now, imagine if we throw the ball with the velocity lower than the Earth's escape velocity, but the ball happens to escape the Earth anyway. That would be very puzzling, right? Now, the solution to this puzzle is none other than quantum tunneling. So in quantum tunneling, we have a particle with an energy of E and a potential barrier with a height of V naught. And the potential barrier has a width of, this is minus A and this is A, so it's 2A. So in quantum tunneling, it says that this particle has a probability of penetrating through this barrier, even though it has an energy much less than the height of the potential barrier. Now, from this problem, there is a solution from which we can derive the transmission coefficient, or we can also call the transmission probability of the particle penetrating through the potential barrier, which is T equals to e to the power of minus 2k2L, in which L is the width of the potential barrier, and K2 is basically this. So that's quantum tunneling, right? Now, what Gamo's theory of alpha decay is, well, what Gamow does is he applies the idea of quantum tunneling to explain the alpha decay process. So he says that basically the alpha particle is able to penetrate the nuclear potential barrier, even though even though it has a kinetic energy much less than the potential barrier. So this is the essence of Gamow's theory of alpha decay. It applies the quantum tunneling to the alpha decay process. Next is the Geiger-Nuttall law. So if we look at, for example, two different alpha particles, with different kinetic energies, in which E2 is greater than E1, we see that E2 only experiences a smaller width of the potential barrier rather than E1. E1 is from here to here, and E2 is from here to here. So what happens then? If we look at the transmission coefficient, because this is minus L, if the L is smaller, then the T becomes larger. Therefore, we can conclude that the transmission coefficient of E2 is larger than the transmission coefficient of E1. This comparison is basically what Geiger-Nuttall law is. Finally, the review. We learned that the alpha particle is identical to the helium nucleus. Then we learned that the alpha decay is a process of emitting an alpha particle in order to stabilize a large nucleus. Then we learned about Gamow's theory, which is applying the quantum tunneling to the alpha decay process, in which we receive the transmission coefficient. And then finally, the Geiger-Nuttall law, in which that says the alpha particles with higher kinetic energy have a higher transmission probability or transmission coefficient. And here are the references from my study. And that's all for me. Thank you.
Okay, thank you, Humaira. We have time for 3 questions from the audience.
Sir, I have question for
Yes.
Humaira.
Yes, go ahead.
Okay, thank you. My question is about the potential. What kind of potential does you or the scientists that write the reference paper use in here?
The the potential here in this
And how
diagram.
they come? Yes, how they come with it? How they come with a number of 25 math?
Oh, that's from an experiment. That's from experiment.
So you mean that what you present is based from the experiment and then the model is just come after it?
Yeah, this is basically from the uh, experiment, and then they model it into this diagram.
Mm.
Okay. So if it's model from the experiment, then what kind of nucleus that was measured to uh, to get this graph?
Oh, this graph is for larger size nucleus, like the ones with a mass number of larger than 210, around that.
Uh, so um, So any nucleus that larger than that has a similar graph. That's what you said.
Yes,
Okay.
that's
Thank you
it.
very much.
You're welcome.
Okay, another question from the audience, please. Okay, Humaira,
Yes, sir.
is there any information about the simulation time
The
that
simulation time.
was conducted in this experiment?
I'm not quite sure, sir. But what simulation time do you actually mean?
In order to get the result?
This result from
Mm-hmm.
this diagram? Oh, I'm not
Mm-hmm.
quite sure, sir, because
Okay.
it's not very explained in the papers.
Mm. Okay. So with that, I guess we like to congratulate Humaira for her presentation. And then
Thank
moving
you,
on to
sir.
the second presenter. Okay, thank you, Humaira. Second presenter is Vikra Dwi Putri Yulianti.
Yes, sir.
Okay, I'm sorry for the uh, delay, etc. and so on. Okay, Fikra will talk about the application of geoelectric method for groundwater potential prediction. Whenever you're ready with your slides, you may start your presentation.
Excuse me, sir. Can you see my slide?
Yes.
Okay. Good morning, everybody, and Mr. Hari. My name is Fikra Dwi Putri
Morning.
Julianti with number ID 102170033. Now I will present my topic. The title of topic is the application of geoelectrical method for groundwater potential prediction. So next, this is outline from my present is first introduction, second is theory, third is method, and next result and discussion, and the last is conclusion. So this is the first. This is distribution of water in the world. The picture of distribution of water in the world. Uh, the first water in the world is only 2%, and this is salt water have 98%, and this is 87% of ice, and groundwater just have 12%, and the last river and lakes just 1%. Water is a unique property of the earth and very important to every living organism. Water is found in many places in the world, including oceans, river, lakes, polar ice, rain, and groundwater. And this is the picture from India, in Chennai, capital of Tamil Nadu, India. They have a crisis of water. So next, this is possible freshwater research. There are ice, rivers, lakes, or dams, and groundwaters. This is theory from groundwater. Groundwater makes up only 0.61% of the total water distribution of the world. Groundwater is more plentiful than surface water. The role of geophysical method in groundwater is to understand to hidden subsurface hydrogeological condition adequately and accurately. Geoelectrical method is required to find the hidden subsurface hydrogeological source. And this is groundwater, this is surface water, and this is the land surface. Next, the pertinence from geoelectrical method is to utilize electrical properties of rocks below the Earth's surface, and the source is either active or passive. And the last resistivity geoelectric is measuring the resistivity value of the soil. This is electrode configuration from geoelectrical method. This is the picture general for electrode rise. And the next, this is geoelectrical configuration from before. The first is Schlumberger array. Second is Wenner array. And third is dipole-dipole array. Schlumberger array have best method for VES and spacing greater depth and easier to operate. And the minus from this method is difficult to consider the layers. And second, the positive from Wenner array is great for profiling or electrical tracing and big picture of resistivity. And the minus is more labor intensive. And third, sorry, dipole-dipole array, and the positive of dipole-dipole is more detailed resistivity of each layer, and the minus is doesn't reach at great depth. This is method. This is a Schlumberger configuration. This is a equation from Schlumberger configuration. The current and potential pairs of electrodes often also have a common midpoint, but the distance between adjacent electrodes differ. And this is equation when where for for row of water, So next, this is Wener eye. Wener eye has special geometry of current and potential electrode for Wener. The current and potential electrode pairs have a common midpoint, and the distance between edges electrode are equal. So that RAC is A and RCB is to A and RAD is to A. This is from the picture, and for rho is to P to P. This is a column divided by I. This is uh, this is ampere, and A from this is the length from from this to this. And the third is dipole-dipole array. The spacing of the electrode in each pair is A, and from in each pair is A, this A, and while the distance between their mid is L, this is long, which is generally much larger than A, and this is for rho dipole-dipole array. The research is conducted in 7 different locations in Simpang Lima, Semarang, and around it at location 1 to location 7. Resistivity value range from 0.0 to 25 and 24.4 ohm meters. This is from study literature. Now, these circumstances are divided into 3 categories or tiers. So this is first category aquifer from 0.25 and until 1 ohm meters, and second one until 10 ohm meters. This is silt, and this 10 up 10 ohm meter. This is sand. And the result from location 1 is it can be estimated that the depth of the basin is more than 53 meters below the surface, and the length limit is more than 130 meters from the expense of data. The next is, this is from location 2. The first basin, the depth is between 15 and until 30 meters below the surface, and the length limit is 20 until 60 meters. The second basin is more than 53 meters below the surface, and length limit from the second basin is more than 133 meters. And this is location 3 is the same from location 1, have 53 below the surface, and the length limit is 133 meters. And this is location 4. The difference from location before is length limit more than 130 meters from the expense of data. This is a location 5. The location 5 have the first basin, the depth from the first basin is between 10 until 33 below surface, and length limit from 60 until 80 meters. And the second basin is have depth between 15 until 30 meters below surface, and length limit have 90 and until 120 meters. So this is at location 6. It can be estimated that the depth of the basin is more than 50 meters below the surface, and the position of this basin is spread evenly across the expanse of data, but with different depth of basin. This is the last location. It can be estimated that the depth of the basin is more than 54 meters below the surface, and the length limit is more than 80 meters from expanse of data. So the conclusion from this present is, first, world water crisis leads some research to extract any exciting freshwater source, and second, since groundwater is more plentiful than surface water, geological methods are required to find the hidden subsurface water source. And third, geoelectrical method is chosen for groundwater exploration because water has a great sensitivity to electricity. And the next Schlumberger configuration is easier to operate and cold spacing greater depth than any other configuration. And the last conclusion is the research in conduction in 7 different locations in Simpang 5 Semarang with resistivity value range from 0.25 until 24.4 ohmmeters, and of all locations, the basin depth and length limit have a similar result. And this is a references. And thank you.
Okay, thank you. We have time for 2 questions for Fikra.
I want to ask, sir.
Yes, please.
Okay. What the meaning of either active or passive from the source geoelectrical methods?
Okay. From this, okay, thank you, Muhammad Ali, for the question. This is either active or passive is the meaning of, if passive, this is the sort of electricity can come from nature. This is passive. There is passive, and active is from the ground. So groundwater have passive source from nature and active source from ground. That's the answer.
Okay. Thank you for the answer.
Okay, any other question from the audience? Okay, Fikra, since the experiment was conducted in Semarang area, do you know what are the reasons why they conduct geoelectric experiments in that area? What are the objective, and what is the problem there?
It just too good for geoelectrical methods. So I choose the seven different location at Semarang, sir. And
Yeah, but the objective is to locate something, or is there any reason why they conduct measurements in the Semarang area?
because I choose my study literature at Semarang is Semarang have a crisis water at crisis water at 20, 20 2021 of first 2021 year at January. So I choose the Semarang for this uh, for this topic.
Okay, so the problem is that they have shortage of water, so they conduct experiment there. Is there any information about the locations where they conduct the geoelectric method? Because do you have a map or plan view about the lines that they have geoelectric measurements?
Excuse me, sir, your voice is not good.
Okay. Hello.
Yeah.
Do you have a map or a description on what location the geoelectric measurement is conducted?
Okay. I'm sorry before. Uh, I just have like this location from studi literature.
Hmm?
They uh they not not to give me a location from Semarang.
Oh, okay.
Yeah.
Okay, because in Semarang, it's not only shortage of water that is persistence there, but also the problem relate to the intrusion of salt water in the northern part of the city, and also probably subsidence is also occurring there. So I'm just wondering what are the reason the geoelectric measurement is conducted. Okay, thank you, Fikrat.
Okay, thank you,
Uh,
sir.
we're going to move on to the third presenter. Our third presenter is Adnan Muhammad Lazwardi, talking about the application of optical fiber sensor for gas sensing.
Hello, sir. My
Yes,
sound audible?
we can hear your voice.
So I will start my presentation. Can you see my screen?
Yeah.
Thank you. Okay. So, hello, Mr. Hari and everyone. My name is Adnan Muhammad Lazwardi, and in this session, I will present my review about application of optical fiber sensor for gas sensing. So this is the outline of this presentation. I will start from introduction of the problem with gas sensing, and then we will dig deeper into optical fiber sensor and fiber break grating, and also distributed leakage monitoring. And after that, we will discuss about sensing principle and then the experiment that have been conducted before. So, hydrogen is can be used as energy carrier in clean and sustainable energy system. It is a new energy fuel, but despite that use, hydrogen has many hazardous characteristics. It has wide flammable range, small emission energy, and ease of leakage due to smaller molecular size. And so to avoid something that we don't want, that might be the explosion of the tank of hydrogen. So for safety, we need a large number of sensor devices that can monitor the leakage of over the wide area. So how can we do that? The sensor that widely used now is semiconductor type sensor, but it could not satisfy the need for distributed leakage detection. And it also has an electrode structure that might accidentally cause a static electrostatic discharge that might be cause an explosion, and that's something that we don't want. And there are another type of sensor that is fiber optical sensor. So it has potential for distributed liquid monitoring, and it also have valuable characteristic such as explosion proof and immunity to electromagnetic noise. So it will not disturbed by the external stimuli that we don't want. And what is actually the actual fiber sensor? So IFS for short is a sensor that based on propagation of light in the core of optical fiber via total internal reflection. As we may know, optical fiber can be used for optical communication, for transmission of information, right? And it transmit the information through the light. But in optical communication case, we don't want the light or the information to be disturbed by the external stimuli. But that's not the case in the optical fiber sensor, because we want to measure the change in light propagation caused by external stimuli. So this is fiber breakgap is one of the mode of several mode for OFS sensor for OFS. So as shown in the picture, FBG has a periodic structure of material that have specific refractive index in the fiber core region. So it functionally will be work as a optical passive filter. So it will filter the wavelength of the light that propagate through the core. It will transmit it will reflect the particle wavelength, and the wavelength that reflected by the FBG or this grating um, is related to the grating periodicity, or this is or the distance between each grating, and also related to the index of refraction, average index of refraction of the grating. And it is stated by the equation on the left. It is Bragg wavelength is two times effective index reflection times grating periodicity. And but how can we measure the change? But how the sensor work, right? So FBG respond to both strain and temperature. The strain will change the grating periodicity, and that's and also effective refractive index, and that might be changed the Bragg reflection, and the temperature will change the the temperature will change the grating periodicity, and that also will change the Bragg wavelength. So this is maybe a no, general application for distributed liquid monitoring. So as shown in the picture, there is a broadband light source that's splitted by the beam splitter. And the one is sent into optical spectrum analyzer, and the other is sent to the sensor device which is the fiber Bragg grating. And each device sensor will reflect a different wavelength, a specific wavelength. So and each wavelength from each sensor device will be combined by multiplex method that we call wavelength diffusion multiplexing method. So so we can have all the information from all sensor device in one reflected wave. So we can use that later for the detection. Yes, and this is the sensing principle. It might be focusing on one sensor device, adaptively distributed sensor device. So there is hydrogen, and in the picture there is hydrogen gas and air. So those two gases will be delivered to the chamber that contain the sensor device, and the reaction between the hydrogen and oxygen will is an exothermic reaction, and it will release large and a lot of heat, right? And that heat will change the um, Bragg graphing periodicity, and that will also change the Bragg wavelength, and that reflected Bragg wavelength will be transmitted into interrogator. So the interrogator um, will collect the information of wavelength shift that uh, can be calculated by the equation in the left, and also interrogator also will collect information about the concentration, because from the Bragg wavelength shift we can deduce the concentration of the gas, and we can have all the information relating to the wavelength shift, concentration of the gas, and the efficiency of the sensor uh, directly on the computer. So this is the experiment that have been conducted before. So the first experiment is an ordinary or just FDG, as shown in the picture of A. So the grating is coated by palladium coating, and when this FDG is exposure, if given the exposure of hydrogen by the concentration of 0.3 to 1.8% of concentration, the wavelength shift is quite low. It is not show the linear relationship between concentration and wavelength shift. So it's kind of bad. And the next experiment is side polished FPG, as shown in the picture. There are 3 experiments that conducted. The first one is palladium tungsten trioxide. By and when so and in this picture we can see that one side of the cladding is etched and have a shorter distance to the grating, and it coated by palladium tungsten trioxide, and by the exposure of 4% hydrogen, it has a wavelength shift of 25 picometer. Another experiment by coating of silver palladium by the exposure of 8% of hydrogen concentration, we can have wavelength shift by 55 picometer. And another experiment, the coating by platinum silicon dioxide by the exposure of 2% hydrogen, we can have wavelength shift by 48 picometers. So as we can see that the coating material that used is directly related to the wavelength shift, and also so that means it has linear relationship with the efficiency of the sensor. And but what can we see from the platinum silicon dioxide, by only 2% of exposure can cause the wavelength shift to almost 48, that kind of close to the second experiment.
Okay, I'm sorry to interrupt, but you have 1 minute to conclude your presentation.
From from this experiment, we can actually conclude that that material, the coating material, is directly related to the efficiency of the sensor, and also the edge treatment. But with edge treatment, it means that we can have more fragile sensor. So if we want to have optimal sensor, we have to balance between the cladding, the edge, or the material. I think that's all from me. This is the reference that I use for my presentation. Thank you. Thank you.
Okay, and thank you for giving us the discussion related to the application of optical fiber for gas sensing. We have time for 2 questions for Adnan.
I would like to ask Adnan, sir.
Yes, please.
Okay, thank you, Adnan. My name is Nazla Inaya. I still don't understand why the percentage of your experiment only in small, only in a little percent in the slide before this. Only 2% or 5%, why? Okay.
Yes, thank you, Nazla, for the question. The paper itself didn't explain why it is why it is so, but what we want is hydrogen leakage detection, right? So you won't have a wavelength shift that we won't have to have OFS sensor that sensitive enough to have a wavelength shift that large enough, but in the as little as possible hydrogen concentration gitu. So that's because why as to why the concentration is what the concentration is little, because that's what we want. We want as little as possible hydrogen concentration, but have the most efficiency. I think that's all I can explain. Is it answer your question?
I see. Okay, thank you, Adnan.
Yes, you're welcome.
Okay, is there any question for Adnan? Okay, if there are no more questions, we would like to thank Adnan for his talk. And then we're going to move on to Abnur Rahman Faiz, talking about a review on carbon dots and its application in biomedical applications.
Okay, thank you, sir.
You're welcome.
Mr. Hari.
Yes.
So I use my laptop to share my screen, but I use my phone to as a microphone because I don't hear any sound. Okay. Yeah. Okay. Good morning, everyone.
Hey, good morning.
Thanks to Mr. Hari for giving me the opportunity to present my presentation. Today, I would like to present my presentation, which title a review of carbon dots and its biomedical application. So I would like to start with the definition of carbon dots. Okay, carbon dots is a zero-dimensional fragment
I'm
that
sorry,
was.
could you close the box there?
I'm sorry, what?
Please continue. Please continue.
Okay. Okay, carbon dots is a zero-dimensional fragment that was dominantly by carbon atoms. Their size is on the scale of few nanometers and they exhibit some unique properties. Carbon dots have promising characteristics, including water solubility, low toxicity, high chemical stability, and easy derivatization. Due to all these unique traits, carbon dots have found important and widespread application in biotechnology, bioimaging, and drug delivery. In general, carbon dots can be classified in two main groups, carbon and graphene quantum dots. The graphene quantum dots are anisotropic with lateral dimension larger than its height and possess the crystalline structure of single or a few graphene layer and connected by chemical group on the edge with circular or elliptic shape. In contrast, carbon quantum dots are always spherical. All carbon dots have chemical group on the surface, such as oxygen or amino base group, and also polymer chains. And this function group play a pivotal role in the photoluminescence behavior. So generally, carbon dots can be fabricated using top-down and bottom-up methods. The top-down approach, by which carbon dots are generally formed through a chemical or physical cutting procedure or relatively microscopic carbon structure. Okay. Compressed laser ablation, then okay, laser ablation, then electrochemical synthesis, and chemical oxidation. Most common representative source for this technique is carbon nanotube and graphite. In bottom-up approach, carbon roots are transformed from suitable molecular precursor under certain condition, exemplified by combustion, thermal or hydrothermal, and microwave or ultrasonic irradiation, wherein the precursor exhibit lower requirement of carbon source. So all the organic matter or bio-waste can be applied as sustainable and cost-effective carbon source for synthesizing carbon dots. Okay, so this figure, we have some carbon source for synthesizing carbon dots and its synthesizing methods. Okay, so carbon dots have been deployed for diverse biomedical application due to their excellent optical properties, also unique electronic, mechanical, thermal, and chemical properties. In contrast to the traditional quantum dots, essentially comprising heavy metal which have known toxicity and hazardous. Carbon dots are much safer and non-toxic both in cell and animal levels. So in the next 3 slides, I will show you the example of carbon dots application in biomedical field. So carbon dots are promising candidates. The first one is bioimaging. Carbon dots are promising candidates for bioimaging purpose because of their low side effect and toxicity, excellent water solubility, and visible to NIR emission properties. In these two figure we the optical image of the carbon quantum dots has been evaluated by intravenous injection into the mouse through the tail vein. In figure A, we can see optical image of the carbon quantum dot in the tumor bearing mouse over increasing time. And in the image B, we can see optical image of fluorescence intensities within the harvested organ after 24 hours from injection. The next application is drug delivery system. So carbon quantum dots possess excellent drug loading capability in view of their biocompatibility, non-toxicity, and photoluminescence properties. Okay, so their small size and large surface area allow rapid cellular uptake with limited influence on drug activity. In 2014, Lee et al. Confirmed that the delivery of doxorubicin in vitro and in vivo using carbon dots. Doxorubicin was loaded on the carbon dots via electrostatic interaction with 95% loading efficiency and induced death of cancer cells as well as a tumor in mice. The next application is for pharmaceutical formulation. In 2015, Lee et al. Have observed that carbon quantum dots can prevent human insulin from fibrillation. So in this experiment, carbon quantum dots, which have been prepared from carbon powder by acid treatment at elevated temperatures, were capable of effectively inhibiting human insulin from fibrillation for 5 days under 65 degrees Celsius, whereas insulin denatures in just 3 hours under the same condition without carbon quantum dots. Okay. Next is the important challenging issues. So one of the important challenging challenge is to optimize the production methodologies and improve the control over the size and morphologies of the produced particle. Yeah. Considerable important variation exists with significant result on related biocompatibility because the fluorescence characteristic and quantum yield are associated with the inclusive composition and the existence of remaining chemical group on the carbon and the graphene quantum dot surface. This standardization is significantly essential. Optimized synthetic strategies are also crucial for scaling up the process, and in this context, applying simple, environmentally friendly, and cost-effective technique are very critical. Okay, so as a conclusion, quantum dots show significant potential in such biomedical, bioimaging, and photoluminescence application. They can be harnessed as promising fluorescent probes for imaging with low cytotoxicity, as they show remarkable potential in bioanalysis and related field. Their optical characteristic can be adjusted by controlling the size, chemical doping, and functionalization for featured and specific application. It appears that there are not many investigations regarding using organism, especially like cyanobacteria, as carbon source for production of fluorescence carbon dots. So more scientific investigation need to be undertaken for scaling up and the commercial production of quantum dots by applying simple, efficient, economic, and sustainable strategies with focus on biocompatibility and low cytotoxicity. Okay, I think that's all from me. Thank you for your attention.
Okay, thank you. We have time for 3 questions for Abdurrahman Faiz. Okay, questions for Abdurrahman Faiz?
Yes, I would like to ask Faiz a questions. Hello?
Hello.
Yes.
All right, okay. I thought my microphone's off. My question is, when and how do you think this technology will become something that commonplace in Indonesia? Because as you said, there's so many useful applications with that technology. So how and when do you think it will become mainstream in Indonesia? Thank you. Or if it will become mainstream in Indonesia in the future.
Thanks for the question. I think I don't know because there are not many there are not many they're not they're not they are there. Okay, I don't know.
All right, that's okay. Thank you.
Okay, any other question from the audience? Okay, if there's no question, is it in the paper that you cite for this assignment? Is there any projections or plan for the application of carbon ducts to be applied, for example, in the treatment of injuries,
I think I
for
haven't
example,
seen
or is it?
someone
Mhm.
using carbon ducts to to
So, for example, if I have bleeding in inside of my body due to some infection, etc., and so on, so would carbon nanodots could be applied there also, the same as for cancer treatment, and etc., and so on.
I haven't seen any or scientists have mentioned it can be applied to injuries, but I have seen a paper that uh, tell that carbon dioxide can be applied to cancer.
Mhm. As you mentioned in the presentation, but uh, for injuries, you didn't see any,
Yeah.
or is your search is not that plenty, or what?
Uh, Maybe my research is uh, lack of that.
Oh, okay, thank you. Uh, with that, we are conclude our session with Abdurrahman Faiz, so that we can move on to the fifth presenter, which is Muhammad Khalid, which is going to talk about composite modeling of pineapple leaf fiber-based composite material using finite element method.
Okay, can you hear me?
Yeah.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Salam warahmatullah.
Good morning, Mr. Hari, and good morning, everyone. I want to present my assessment, scientific communication, in 50 minutes oral presentation. This is my topic, composite modeling as pineapple, leaf fiber-based composite material using the finite element method. So there are several outline other background of this topic, that the definition of composite materials, the analysis of finite element method, the finite element method FEM, result of ANSYS instrument and on composite material, and conclusion. So this is background of this topic. In Indonesia, pineapple plants are one of the plants that can thrive due to various factors such as climate, temperature, rainfall, and several other factors. The pineapple plant produces fruit that can be consumed by the community, but this leaf become waste for the environment. Pineapple leaf cluster is widely used as paper and textile material. Pineapple leaf can be processed into textile, paper, and composite. Um, the potential of pineapple in Indonesia is the 50th largest in the world. So all are very important to increase their surviving value, one of which is that pineapple plant need to use pineapple frond to make fiber as an environmentally friendly composite material. Pineapple fiber consists of cellulose and non-cellulose, which is obtained by removing the off layer of living mechanically. So this definition uh, of composite material is a type of new material resulting from engineering, which consists of two or more than two materials that where the properties of each of these material differ in their physical or chemical properties. It is easy to design the composite into any shape. One of the main reasons for using composite materials is the high strength, but material obtained with a much lighter weight than conventional materials. Next, is the analysis of the FAM. The basis of FAM relies on the composition of the domain into a finite number of subdomain elements for which the systematic approximate solution is constructed by applying the variational or weighted residual method. In effect, FAM reduces the problem to that of a finite number of unknowns by dividing the domain into element and by expressing the unknown field variable in terms of the some approximating function within each element. This function also called an interpolation function are definite in terms of the values of the field variable at specific point referred to as nodes. Nodes are usually located along the element boundaries and the connect agents element. Then the FAM is numerical procedures that can be used to obtain solution to a large class of engineering problems involving stress analysis, heat transfer, fluid flow, etc. So that and this is general purpose finite element modeling package for numerically solving a wide variety of mechanically problem that include static, dynamic, structural analysis, both linear and non-linear heat transfer and fluid problems, as well as acoustic and electromagnetic problems. So this is the finite element method. The finite element method is a powerful computational technique for approximate solution to various reward engineering problems that have complex domain subject to common boundary conditions. This is data acquisition, data processing ANSYS, next thermal conductivities, epoxy composite. So based on this research, will discuss about heat transfer, simulation in layers, the middle of the plate. The heat equation used is solved numerically using the finite element method with the linear quadrilateral element from a function which has 4 nodes. Yeah, using the finite element program ANSYS, thermal analysis is carried out for the conductive heat transfer through the composite body. In order to make a thermal analysis, three-dimensional physical models with sphere in a group. Lattice array have been used to simulate the microstructure of composite material for different filler concentration. Furthermore, the effective thermal conductivity of this epoxy composite fillet with fine wood that's up to about 36% by volume is numerical determinant using ANSYS. This is a result of ANSYS in composite material. Pick one temperature profile for composite with particle concentration. Volume 615%, B 11.3%, C 26.8%, D 35.9%. In the numerical analysis of the heat conduction problem, the temperature at the nodes along the surface ABCD is prescribed as T1 100 Celsius, and the convective heat transfer coefficient of ambient is prescribed as 2.5 watt per meter cubic Kelvin at ambient temperature of 78 to 27 Celsius. The heat flow direction and the boundary condition are shown in Peak 1. The others face parallel to the direction of the heat flow are all shown adiabatic. This is the simulation result of the infinite element method in the form of temperature of composite with particle concentration. The temperature at the nodes in the interior region and on the adiabatic boundaries are unknown. Thus, temperature are obtained with the help of finite element program package ANSYS. In the analysis of the ideal case, it will be assumed that that the composite are macroscopically homogeneous locally, but the matrix and filler are homogeneous and isotropic. Yeah. This conclusion in numerical methods and experiment on the thermal conductivity of pinnacle fiber weight, it is concluded that, among other things, the fabrication of pinnacle fiber-based composite filler with micro size can be carried out. A method can be used properly to determine the equivalent thermal conductivity pinnacle fiber composite with the amount of different filter. And next, the thermal conductivity value obtained from the composite model correspond to experimental values to range of 6% to 36% filter, and their conductivity values for FEM analysis are more accurate. Yeah. So.
Okay, thank you, Muhammad Khalid, for the presentation. We have time for 3 questions on this topic. Okay, is there any question from the audience related to the? Okay.
Yes, I have a question.
Please.
How is the process of forming pineapple leaf fibers into a composite materials?
Okay, thank you for the question. I think composite materials are composite of two types of constituent material, namely matrix and fiber. The fiber has the properties that is easy to change its shape by cutting of printing it according to its design needs. And the matrix is generally made of resin, uh, serve as an adhesive adhesive for fiber materials, so that the peel of fiber stick together firmly. The resin will bind the fiber materials to each other, so that the load imposed on the composite will spread evenly.
Okay, is that answer your question?
Yes. Thank
Okay.
you. Bye.
Okay, you have
Okay. Any other question from the audience?
Hello.
Yes, please.
I thank you for me. I want to ask how to determine the effective properties of composite material by functional design and application for that for of composite material. Thank you.
Okay, thank you for your question. I think the effective properties of composite materials is one of the important factor. Is the microstructure of the composite, because microstructure means the shape, size distribution, spatial distribution, and orientation distribution of the reinforcing inclusion in the matrix. Although most composite process inclusion of random distribution, this is a great insight of the effect of microstructure on the effective properties can be gained from the investigation of composite with periodic structure. System with periodic structure can be more easily analyzed because of the high degree of symmetry embedded in the system.
Okay. Any more questions from the audience for Muhammad Khalid? Okay, so the simulation is work on finite element method. Do you aware what type of elements that they use in the computation? Is it a default? Is it a default element such as tetrahedral or triangle, or the user or the scientist make some kind of a custom elements for the study? Do you have any information about the shape of the elements that they have for the simulation?
Okay, this is not a computation, but this is a make it program ANSYS, program ANSYS. Yeah, this that because exists as purpose definite element modeling package for numerically solving a wide variety of mechanical problems.
Yeah, and so the simulation is in 3D, right? Three-dimensional, or is it 2D?
Yes.
Three-dimensional?
Um, yes, sir.
Okay.
Three-dimensional.
Okay, so I assume that the size or the shape of the element is tetrahedral, and then because it's typical for finite element methods, uh, but we can also customize the shape of the elements so that it will match the shape of the material being used here. But I guess the subject here doesn't have that complex geometry that need to do some modification in the shape of the elements. But okay, so I guess that is all of Muhammad Khalik's session, so that we can move on to the last presenter of today, which is Alika. Okay, thank you, Muhammad Khalik,
Okay, sir.
for your presentation. Alika is going to talk. Well, actually, Alika's session is supposedly done in Monday, but due to the circumstances, due to some circumstances, she needs to postpone her presentation. Alika is going to talk about EEG application in recording of brain activities and the international 1020 systems, which is related to the uh, 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 medical physics.
Yep.
Yeah. Mhm. Okay, the time is yours.
Okay. Bismillahirrahmanirrahim. I am Alika Rahma Gumilar, a physics student with student number 102-17013. Today in this scientific presentation, I will present and talking my writing about electroencephalography as recording as electrical recording of brain activity and the international 1020 system. The outline of today's talk is first, I'll talk about the introduction. Second, the nervous system and brain. Third, I will discuss about EEG. Fourth, the international 1020 system. And fifth, lastly, I will show one of the most cases, VIMS, and how the EEG can explain this phenomenon. Let's start here. Let's start from this fact. The human brain is like nothing else. It doesn't expand and shrink like the lungs, pump like the heart, or secrete visible material like bladder. If you slice up the top of someone's head and peer inside, you wouldn't see much happening at all. Given that, it is perhaps not surprising that for centuries, the content of our skull were regarded as relatively unimportant. And back then, when they mummy their dead, the ancient Egyptians scoop up the brain and just threw them away. But human, as thinking creature, they begin to questioning what is brain? What does it do? So the ancient Greek philosopher Aristotle thought that brain was a radiator for cooling the blood. And we have Rene, the French scientist, thought that it was a sort of antenna by which the spirit might commune with the body. And finally, it is now that the full wonder of the brain is being realized. Now we have that the most basic function of the brain is to keep the rest of body alive. The brain generates the emotion, perception, and thoughts that guide our behavior. Then it direct and execute our action. And finally, it is responsible for the conscious awareness of the mind itself. And let's start here. Over the following years, scientific and technological advance have fueled a neuroscientific revolution. A growing understanding of electricity allowed the dynamic of the brain to be recognized and to be observed and measured with the advent of electroencephalography or EEG. So today I'll talk about EEG as electrical recording of brain in general. Okay, the brain is the part of the central nervous system. The nervous system, which is present in all vertebrate and invertebrate, is concerned with the universal trait of life called irritability, which is the ability of a cell and all organism to respond to changes in its internal or external environment. And various factors can influence human response to changes, such as information they have, understanding the phenomena, the nature of decision-making process, and the motivation for the change, for change. So, sorry. So if you and your friend are playing roller coaster together and feel dizzy and nauseous, it happened because your body sends pass the information about how they feel, such as the shaking, the vibration, and so on to the brain. And finally, the brain will respond. The brain is broadly divided into cerebrum, cerebellum, and brainstem. And in the cerebrum, there are many neurons, especially the pyramidal type, which play an important role in EEG recording of brain activity. And in the brain, neurons communicate with each other via electrochemical signals. The electrical signals arise from action potential generated within each neuron. An action potential is the rapid change in voltage within a neuron. And the process leading to this began with a difference in charge between the inside and the outside of the neuron, called an electrochemical gradient. And at rest, the electrical charge within the neuron is more negative than the charge outside of the neuron. However, when neuron receive a signals, positively charged ion flows into the neuron. This changes the permeability of the cell, thus letting more ion across the membrane, causing an upward spike in voltage, like in this graph. The upward spike in potential travel down the axon by increasing the permeability of the next location of the membrane. And as you can see in this graph, this is a graph time function in region 1. This region describes the neuron potential at rest, minus 70 millivolt. And this, when neuron receive a signal, the potential reach the threshold. And then the potential decreased due to the ion channel in the neuron. Although action potential are the electrical language that neurons use to communicate, they are not the signal EEG actually measure. Why? It is because the action potential is very quick. When the presynaptic neuron here release neurotransmitter, the blue circle, the neurotransmitter binds to the postsynaptic receptor on the next cell dendrites. Like in the action potential, this binding trigger an increase the permeability of the cell, and then these changes are postsynaptic potential. And postsynaptic potential lasts far longer than action potential, but are also smaller in amplitude and weaken as they travel. The lower timing and a larger span of postsynaptic potential are the reason why they are better for EEG recording. This is how EEG do the recordings. The postsynaptic potential is divided into excitatory or EPSP, this one, which makes the positive ion flow into the cell, so the space become more negative, and this space become more positive, and a dipole is formed. Beside EPSP, there is inhibitory or IPSP, which make different ions flow into the cell, so the space become more positive, like this. The system which EEG electrode apply to the head and then display an EEG recording is called the International 1020 system. This system is standard method for measuring the head and placing electrode. It depends on 4 main positions on the head that are easily transferable between the patient. First is the nation at the bridge of the nose, like here, and then the Indian, the bony prominence at the back of the head, and then 2 preocular point on each ear. Okay. And through the image of the head seen from the above, like this one, we can get the electrode placement of the International 1020 system. The first measurement is made from the nation, like here, to the Indian, front to back. This measurement is then divided into 10 and 20% increments, and we mark the place. And then the measurement is made from one preocular point to the other. Again, this is divided into 10 and 20% increments, and additional marks are made. And then further marks are made around this circumference, lingkar, of the head and separated by 10% increment and mark the place. And then parasagittal measurement are made, the vertical one separated by 25%, like this image. And finally, the intersection of these 2 lines is where the final electrode are placed. And once all of these marks have been placed, the electrode can be applied to the scalp of the patient. We already know how the EEG work and the placement of electrode by the 1020 system in general. Now let's discuss one common case, which is VIMS, or visually induced motion sickness. It says that VIMS is a major problem for movies viewers, so entertainment becomes a fatigue for those viewers who are affected by this symptom. Riding a roller coaster and then feeling nauseous and dizzy, that is motion sickness. But if you watch 3D movies or playing game with VR, that is VIMS, because motion sickness is caused by visual stimuli. 3D film influences us to think that an object is close or far and has a depth, so they trick us. So there is one of the experiment regarding VIMS by Mr. Nakfi in 2015. This is part of the experiment result. Nakfi shows the result in various group of waves such as gamma, beta, and so on. But here I only focus on the result of the alpha wave. Why? Because in the other paper, it was reported that alpha power increase in parietal region with increase in subjective motion sickness level. So let's just focus on parietal region. That is on the half down area of the brain and on the back. From here, we can see that in 4th and 8th minute of 2D group, alpha power increased in occipital region. That is on the back, the head. And while in the 3D group, it increased in 4th, 6th, and 8th minutes in parietal and occipital region. So with that, we can conclude that this experiment explained that 3D groups or 3D stimuli is more likely to be motion sick.
Okay, I'm sorry to interrupt. You have 1 minute to conclude your talk.
Okay, that's it. EG in general and a little bit of example on VIMS. Thank you very much.
Okay, we have time for 2 questions for Alika. Okay, is there any question from the audience related to the presentation topic? Okay, Alika.
Yep.
In the example that you shown here, the EEG is used for detecting the impulse that is coming out from motion sickness patient, right?
Yep. Yeah.
So, and this motion sickness is due to the fact that the patient is see too many. The patient is exposed too much with the monitor.
Yeah. Mr. Nakfi in 2015 in this experiment, he used VR, HMD, the glasses one, and the subject is watching the 3Ds and 2D movies for 10 minutes.
So, okay, so I wonder if the motion sickness is due to the motion, a real motion that is happening, for example, inside of a car. So will the virtual reality device and the actual activities, for example, inside of a car will be relevant enough so that the motion sickness is actually comparable between the motion sickness from the car with the motion sickness that is gathered using VR? What do you think?
I think if we watch some movies in the car, a real car, it is absolutely will affected because it also affects the balance, our balance. So we must feel dizzy and nauseous. So we feel the motion sick.
Would be the same experience when we have that exposure with the virtual reality glasses, for example?
I think
because
it
because
won't be
here
the
in
same. I think.
so because I guess there were study, okay, in EEG in terms of detecting motion sickness uh, where they actually put a patient inside of a car and then they detect what kind of brain activities that can be activated when he or she or the patient itself having troubles in terms of balancing the motion. So using VR, okay, using VR goggles is one of the approach that doctors and scientists could have in order to uh, make some kind of a diagnosis, alternative diagnosis in terms of studying motion sickness. But uh, but there are but it is true that motion sickness can be triggered from several mechanisms. Uh, uh, but and one of them is coming from the imbalance of amygdala in during people drive in the car, etc., and so on. So probably the study using VR will be beneficial, but a correction must be included, I guess, in the study in order to get some kind of a one-to-one comparison between an actual motion sickness in some vehicle with the motion sickness induced by virtual reality. Okay, thank you, Alika. And with that, I think we are concluding our activities in FI4005 Scientific Communication class for this semester. I would like to thank everybody in participating the activities. We still have two more activities need to be done, which is the writing of paper and the completion of your poster presentation. Which date for the poster presentation deadline would be the same date of the final exam. And if I'm not mistaken, if we look at the SIX website, the final exam date for scientific communication, it will be on May the 28th, 2021. So make sure that you able to work together during the holiday season. And I wish good and happy holiday week for those who are celebrating Eid in a couple of months. So uh, uh, please submit all of your PPT or PDF of your presentation file into the corresponding folder in the LMS. And also please submit your final paper not before the deadline for the final paper. Okay, so thank you all for participating in the class. It is a great pleasure for me to teach you all about one or two things on a scientific presentation. Maybe the delivery of the materials is not that superb as you may expect it, but I'm trying my best to deliver the material and prepare you with the exposure to great teachers that readily available on YouTube and other online materials. And with this, I will conclude our class for this semester, and I would like to thank everybody for their participation. Okay, thank you all, and we're going to meet you again in other activities, hopefully in healthy and happy condition. Okay, thank you all, and good morning.
Thank you, sir.
Thank you,
Yes, sir.
sir.